Hello, good day viewers. In this tutorial, I would like to derive two important formulas that connect a sector and a cone. So if you are new here, consider subscribing. Press the bell icon so that you'll be notified whenever I upload a new content, and don't forget to share to your learning colleagues. Let's get started. I have already constructed my sector, and I use the same sector to form this cone. You know that we fold a sector to form a cone. Sometimes an examiner might give you just a cone and ask you to find that angle of a sector that was used to form the cone. So this is our first formula. Let's start from here and stop here. We have an angle of a sector here. This length here is what we call the arc length, and this is the radius of the cycle. So let's start here. What is the perimeter of a cycle? Perimeter of a cycle is equal to 2 pi r. But since this is just a portion of a cycle, we have to use what? Angle subtended by that sector divided by 360 degrees, which is the entire cycle. Then we multiply by that 2 pi r. So remember, I told you it is equal to what? 2 pi r. I'm going to use capital letter here because I have used small letter r here. This is perimeter of a cycle, or let me say circumference, right? But since we are talking about a portion, we have to take that angle subtended by that sector divided by 360 degrees. So this is L. Let's go to the other side. One thing I would like you to remember is that if you fold this one from this end to this end, you have a cone. Therefore, this L will now turn to be what? In the base of the cone, which is the circumference of the cycle right here. So what is the circumference here? Circumference C is equal to 2 pi r, but this time around small r since we have small r here. And I told you that C, this particular C, which is the circumference of this cycle, is equivalent to this L from our sector. So C is equal to L. So why not just replace L with C? So instead of L, we are going to write C, right? And our C is 2 pi r, which means that the whole of this will be equal to this. Theta all over 360 degrees multiplied by 2 pi r, capital R, is now equal to 2 pi small r. This 2 pi will cancel this 2 pi, and we can divide both sides by capital R, right? Leaving only theta divided by 360. So we have, or should I do it directly? Yeah, we can divide both sides by R and multiply both sides by 360 degrees. So therefore, theta is equal to small r divided by capital R multiplied by 360 degrees. And hence, this is said to be the angle of a sector that was used to form the cone. But the question is, what is this R? Because from the cone, we do not have this R. This R is the radius of the sector, but this radius is now the slanted height of the cone. Just observe, once you fold it here, it will be the slanted height of the cone. Therefore, we are only going to replace this R with S, but in some textbooks you see L here for slanted height. The reason why I use S is because I have already used L for the sector. So finally, we have the angle of the sector to be equal to small r over S multiplied by 360 degrees. So whenever you're given a cone and asked to find the angle of a sector that was used to form that cone, use this formula. Take the radius of the base of the cone, divide by the slanted height of the cone, then multiply by 360 degrees. So this is just the relationship between this and this. That is number one. And the second relationship I would like to establish here is the curved surface area of the cone. I would like to derive that formula. Very important. But let me start here. You should know that this surface is equivalent to this surface, because the moment you fold this surface will be the curved surface area of the cone. What is the area of this? Remember, area of a cycle, let me start here. Area of cycle is what? Pi r squared. I use capital R because we have capital R. But this is just a portion of a cycle. Therefore, you have to take theta divided by 360 degrees. So this is what? The area of sector. You should know that. So the only thing we need to replace here to find the area of the curved surface area of the cone is this angle and R, because R here is equivalent to S here. So let's replace the two of them. So the curved surface area of the cone will now be theta. Remember, theta is R over S times 360. R over S times 360 degrees. But since we have divided by 360 here, we have to do the same thing here. They are multiplied by pi. I told you that R is equivalent to S, so we have S squared here. This 360 will cancel this 360, and what we have is R divided by S, then multiplied by pi S squared. So one S will go here exactly one time, and it can go into one of the S's here because this is S times S. All we have left is R pi S. So this is R pi S, but let me start with pi R S. Therefore, the curved surface area of a cone is pi r s, but in some textbooks you see something like this: pi r l, for which L is what? The slanted height. But you know, these are just variables for declaration. Since we have declared the slanted height with S, therefore we have to use this. But initially, suppose we use L here, it has to be in this form. Therefore, the area, the curved surface area of a cone is pi rs. As simple as that. Thank you for watching. Do share to your learning colleagues, and don't forget to subscribe to my YouTube channel for more exciting videos. Bye bye.